again, Web Multipliers YouTube channel. Today I am going to say you about vectors. You know, before going to start any chapter, you think it is easy chapter. Then you can do any problem, or if they ask anything from the chapter, you can do. Just you have to assume that it's easy. अरे बहुत आसान है यार, डेफिनेशन समझ लो तो प्रॉब्लम्स भी कर सकते हो. चलो स्टार्ट करते हैं. वेक्टर, व्हाट इज द मीनिंग ऑफ द वेक्टर? वेक्टर बोले तो क्या है? वेरी इजी. वेक्टर डेफिनेशन यू which contains both direction and magnitude is known as a vector. What which contains both direction and magnitude is known as vector. What is direction? We all know the direction. See, this is going this side. It's direction. Suppose I am moving this side. I am moving in this direction. I am moving like this. It's my direction. Like that only. Magnitude. What is the meaning of magnitude? You know, magnitude means you see here. See, this we measure the length, that is known as the magnitude. See, for a vector we are measuring its length, its magnitude. You know, magnitude means length. You know, but we have to use these like words. Just simple. See, like that only. Now we are going to discuss about types of vector. What is scalar? Scalar means which contains only magnitude. Vector means one which contains both direction and magnitude. Scalar means which contains only magnitude. It's easy. Now we go to the types of vectors. First one is like vector. See, first I draw the diagrams for easy understanding. If we see the diagrams, we will understand. See, like vectors, which means their direction is same but their magnitude is different. See, I will write nicely. Like vector. See, means its direction is same. We all are moving in a same way. But suppose here to there is a door. I move up to here, but my friends move up to there only. It's an example for like vector. For understanding in an easy way, see, these three vectors are moving in a same way, but their magnitude is different. Just that's all. See, they are all are moving in this way. No, they are moving in this way. All are moving in the same way, but their magnitude is different. Understood? See, there you can see one vector is this much. 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 See, even though they are moving in the same way, their magnitude is different, their direction is same. They are known as the what? Like vectors. Now, let us go to unlike vectors. See, they act on opposite direction. See, like we have learned, so you get unlike also very easily. What's useful is there I am saying in the book, so what it will be useful for you. You know, you should not buy out the definition. You have to understand the definitions and you have to remember. That's all. You will get the total vectors. See, now unlike vectors. Unlike, no need of writing vectors, already there we are discussing about vectors and you know. See, unlike vectors which are there, see example, which are moving in a opposite direction. You know, like vectors, in the case of like vectors which were moving in a same direction, which were moving in a same direction, but it's opposite. It's just opposite of like vectors. No, it moves in a different manner. See, you have to just understand if he has given in an exam paper what is like vector, what is unlike vector. If you get any, suppose you know the definition of the like vector but you don't know the definition of unlike vector, then what you will do? You know, it's just easy. It happens just easy because unlike vector is just opposite of like vector. Like vector is just opposite of unlike vector only. No need to verify. If you get one definition, you get two definitions. It's so easy, In this case only, what happens? Unlike vectors, both are reversed. Opposite of like vector. You can simply remember like this, Like this vectors only, there are equal vectors and equal vectors. See, like that only equal vectors means there. Suppose I am drawing a vector. See, up to here I have drawn a vector. See, both are moving in the same direction. Both are moving in the same direction. ये रफ वे बॉक्स समझ लीजिए थोड़ा. कौन करता है यार परफेक्ट. रफली डायग्राम कर रहा हूँ. आपको ये सिर्फ वेक्टर्स को देखे दो, एरोस को. वो बोर्ड की मैग्नीट्यूड सेम है. और इसका भी देख लीजिए. इसका भी मैग्नीट्यूड सेम ही है ना. देख अब listen, both are moving in a same direction, both magnitudes are same, then they are known as equal vectors. कौन लिखता है पूरा नेम वीडियो में? तो सीधा शॉर्ट फॉर्म में लिख लिया हो, समझ लिया थोड़ा सा. सी लाइक वेक्टर्स कंप्लीट हो गए, अनलाइक वेक्टर्स कंप्लीट हो गए, स्केलर कंप्लीट हो गए, नेगेटिव वेक्टर्स नो. सी दिस इज ऑल्सो ए नाइस कॉन्सेप्ट. Negative vectors, you think negative vector, this is a positive vector, this is a positive vector, but when I bring it into negative, it becomes like this. See, like that only here is there, minus a bar. Here there was, see, plus a bar, minus a bar. See, I am drawing the same length, but when we keep minus mark, the direction changes. Understood? Suppose you think like this, only some examples I give. Negative vector means if a vector is like that positive, it changes direction to opposite side. Understood? Like that only I give now some examples. See. Suppose it's a bar. It's a bar, right? If I add plus 3 to it, see, the length increased. Here magnitude is less. But when I am adding a number, its magnitude is increased. See, like that only. In this case only, you can understand the negative vectors very easily. See, if I add this, for this a vector, it becomes like this. Now, if I make it minus 1, it becomes 2a bar. That's all. It's decreasing and increasing. That only. When we comes to negative, it becomes like this. In this direction didn't change. Direction didn't change, no. But negative, the direction change. When we convert positive into negative, the direction changes. Again, total same. Just direction changes, but total are same. I think not up here for you. I am writing this here. See, if I add 3 to this, see, same to same as positive vector, but in the case of the negative vector, just direction is changing. That's all. This also we no need to verify. What we do? We keep like this book in front of us. We read definition like this. We see the diagrams. We add the diagrams also, and we go to exam. Nothing we can remember. Don't verify. Just simple logic. If you get like vectors, you get unlike vectors also. If you get positive vectors, you will get negative vectors also. Positive vectors I have explained, negative vectors I have explained. Why? Because if I know one definition, I can know another also very easily. See, now null vector. What's null vector? You know, basically suppose I give an example now. See null vector, no? Null or zero vector, null or zero vector, null or zero vector, null or zero vector you think, or null vector, anything we can write. So I am writing zero vector. See, suppose vector a bar and b bar are equal. What? Vector, if two vectors are there, a bar and b bar, what? Two vectors, a bar and b bar. A bar and b bar, two vectors are there, you know, but now you see a bar and b bar is there, no? If I write this, both are equal, this both are equal in length, magnitude, anything you think, but this both are equal I wrote. Then see, this only I will write as a bar minus b bar, okay? I write it as a bar minus b bar. Now suppose 1 comma 1 are equal, 1 comma 1 are equal, so now see 1 minus 1 equals to 0, no? But see, like that 1 minus 1 is 0, no? Like that a bar minus b bar equals to 0, you can't write this a bar minus b bar. It's wrong, it's totally wrong. अरे यार सेंस नहीं बनता यार कुछ भी, क्योंकि वेक्टर लिख रहे हैं उसके बाद माइनस करके इक्वल करके जीरो लिख रहे हैं, कुछ भी सेंस नहीं बनता ना. सो दैट्स व्हाई वी राइट इट एज, now only I have said that a bar and b bar are equal, a minus b bar equals to, a minus b bar equals to 0 bar. I am writing 0 bar. Now it makes some more sense. मैं लिख रहा हूँ सीधा 0 लिख रहा हूँ तो कुछ भी सेंस बनता है उधर? नो. सो वी डिनोट null vector with 0 bar. What? We denote 0 vector or null vector as 0 bar. You know, we are going front. This is part 1, part 2, part 3. We are going front. On that time we get a problem like this. You can't write 0, no. So basically for doing problems also it may be used. See, now another very important vector is also there. We discuss about it. See, suppose parallel vector. See, one vector is moving like this, another vector is moving like this. This both are parallel, that's all. Equal means like this. Suppose these all vectors are parallel, no? You know, parallel means suppose I am a human. See, रफ डायग्राम है, देख लीजिए, और इधर से अनदर ह्यूमन जा रहा है. सपोज ये रोड है, इट्स ए रोड. आई एम गोइंग लाइक दिस एंड vehicles are moving in this. I am and vehicles are equal side going. I am going like this, this vehicle is going like this. We both are equal? No, we are parallel vectors. See, that's all in parallel vectors. Definitions are small, but in problems you have to just understand the concept. Now come to very important thing, unit vector. See, in this only we are going to learn about a cap, comma j cap, comma k cap. See, a cap, j cap and k cap we use in problems more, but many of them don't know that why this a cap, j cap and k cap as came. Many of them don't know. See, simply yaar, why are you wasting time? How this came, you know? See, this is a vector, it is a vector. Listen, see, it's a vector, right? In this, suppose it has this much of magnitude. See, unit vector Unit vector, no? Unit means in name itself is there 1. Unit means what? 1. Unit means what? 1, no? Simply we can write. See, we need 1 unit in this vector. So, we will assume as up to year to year. It's a vector we assume. Up to year 1 unit we assume and we write it as A cap. We write it as A cap. We are, it's a unit we are taking and we are denoting that unit as A cap. Like that only, like this vector is going. Like that only I am taking this much of unit and I am denoting it as J cap. See, easier. Just J cap, K cap. What is the K cap? Before going to discuss, we discuss how we write as magnitude. What's the symbol for magnitude? See, we are discussing all main things, but magnitude how we denote magnitude, it's also main only, no? See, like this a vector A bar. So listen like this. See, it's magnitude, no? We just denote it as mod A. See, like that mod A bar. See, like that we denote it as, okay? Have you understood? Like this we denote magnitude. Listen, like that only. Now K cap. How K cap has come? See, we all know the quadriants. But see, suppose you think it's I am drawing, right? No? Like this I have drawn. See, now from this I am taking a unit and it's A cap. Okay, this we have discussed, it's A cap. Now like that only we are taking here some units and I am denoting it as J cap. Like that only I am drawing another line and naming it as Z. It's X, it's Y. See, now here I am taking some unit and I am writing it as K cap. Based on this, some interesting question is there. We discuss a question at last. Why only theory we want to discuss? We discuss a question, right? This A cap, J cap and Z cap we have get. Now you listen. Suppose now we discuss a problem, right? Some problem like question, some problem type question. Suppose a vector is like this. A vector is like this. I am changing its direction to here. I am changing it. I am taking that vector and keeping here. Nothing happens. No. It's see rough diagram. You just think it's same direction. This vector is also going like that and this vector is also going like that and they have same magnitude. I am not changing in the magnitude, I am not changing in direction. If from it goes, what happen? Just like that only this vector is going. I have taken that vector and simply kept it. Nothing happens. No, this direction I am not changing, its magnitude I am not changing. See, now suppose, see, listen. There is a room. रफ डायग्राम में समझ लीजिए कौन परफेक्ट रूम ड्रॉ करता है, समझ लीजिए. समझिए ये एक रूम है. मेरे को भी रूम जैसे लग नहीं रहा है मगर समझ लिए. इमेजिन सपोज ये वाई एक्सिस, एक्स एक्सिस एंड इससे यूनिट ए कैप and its J cap I am denoting as J cap and this what? K cap. See, I have given a point here and I have said that meet these axes with this point. Now what you will do? Now all will do, here line means here they will draw line, here line they will draw, they all use logics. But just now I have said, if I am writing a vector like this, same vector, I I'm not changing the direction. I'm not changing the magnitude. Simply I'm writing. No, that's all. You take here one vector I have drawn. No, just you take this vector and keep here. What it's become? It's interacting. It's intersecting with this point. Now only I have said it's. I think not understanding diagram is. So I draw again. You just listen. Suppose here is a vector and the here point is there in a room. कैसे लगा उसको मुंडे किए तो इधर पॉइंट है ये जे कैप के कैप और ए कैप मैंने बता दिया तो टिक छोड़ दे तो यही वेक्टर मैं इधर ड्रॉ कर रहा हूँ सो इसका मैग्नीट्यूड में चेंज नहीं कर रहा इसका डायरेक्शन में चेंज नहीं कर रहा सिंपली मैं इधर लिख रहा हूँ उतना इतना मैं इस तरफ चल रहा हूँ थोड़ा इस तरफ आ गया फिर भी सेम डायरेक्शन में चल रहा हूँ ना थोड़ा टेढ़ा मैं नहीं कर रहा हूँ ना ठीक है ना तो वैसे इस वेक्टर को लेकर इधर रखिए तो इस वेक्टर को लेकर इधर पॉइंट को इंटरसेक्ट कर दीजिएगा हो जाएगा ना आसान बात है ना तो ठीक है आज के लिए बस इतना ही आपको वीडियो पसंद आया तो लाइक शेयर सब्सक्राइब एंड कमेंट कर दीजिए